Today we are going to look at the last section of Chapter 6, Section 6.9, Similar Figures. This section is going to correspond very closely to last Thursday's lesson, 6.7, when we talked about size changes. So if you remember, we looked at objects and how they underwent a size change. So if we look at these two triangles, we would have said that the small triangle, we'll call that our pre-image for now, and the large triangle, our image, underwent a size change. So if you remember, if we went from small to big, we would have called that an expansion. And if we would have went big to small, we would have called that a contraction. So again, this is all review from 6.7 when we talked about size changes. However, regardless if we're talking about the small triangle being the preimage or the large triangle being the preimage, it doesn't matter. What we want to notice for today is that these two figures have the same shape. Alright, they are both triangles, which is very important as far as what we're looking at today. So to define similar figures, we can say that similar figures are two figures of the same shape but can have different sizes. Alright, one more time. Similar figures, two figures that are the same shape but can be of different sizes. So let's practice drawing a few examples of similar figures. Would these be considered similar figures? Yes, because they are the same shape. They are both rectangles, just different sizes. So again, they've underwent a size change, but that's still what is defining a similar figure. However, I have a circle and an oval, approximately the same size. Are those similar figures? These are not similar figures because they are not the same shape. So one more time, similar figures have to be the same shape. Alright, now we're going to look at two special properties of similar figures. These two things are basically what's going to help you complete any problems, solve any of your homework things today. Okay? So the first property we want to talk about is that in a similar figure, corresponding angles have the same measure. Okay? Corresponding angles have the same measure. Corresponding, remember, means that they are the angles that match up between the two shapes. For instance, if I were to draw two triangles, okay, and these are similar because we're talking about properties of similar figures, we would label these figures, and I'm just going to give them some labels there, okay? So we can talk about angle A, angle B, and angle C of our larger triangle. We can also talk about angle D, angle E, and angle F of our smaller triangles. Okay, so let's first talk about which angles correspond. Angle A corresponds, or is in the same location, has the same part in the smaller triangle as angle D. B matches with E, and C matches with F. Alright, so those are the corresponding angles. Now, going back to this property is telling us that corresponding angles have the same measure. So that means that A and D have the same measure. That little mark in the triangle means they have the same measure. Likewise, C has the same measure as angle F, and last but not least, angle B has the same measure as angle E. Knowing this, I could say that if angle C is 65, how big is angle F? Also has to be 65. Angle B is 100. Angle E is 100. So forth and so on. So that is our first property of similar figures. The second property of similar figures that we need to understand is that ratios of the lengths of corresponding sides are equal. Okay, again we see that word corresponding, but this time we're talking about the side lengths instead of the angle measures. So again, the ratios of lengths of corresponding or matching sides are equal. Okay, so I'm going to draw those triangles again. Notice again they're similar, they're both triangles, but they're not the same size. Alright, I'm going to label them again. And I'm going to give them some side lengths. So I'm going to say this is 1, this is 2, 3, 6, and 9. Okay, so now what we have to do is talking about matching up the corresponding sides. So I want to look at the ratio of AC, that's side AC, so from A to C. What side does that match up with on the smaller triangle? That matches up with DF. So our ratio of our big triangle to small triangle, I could say one of the ratios is AC to DF. I could look at another side. AB would match up with DE. And I don't have to go big triangle first. I could go small triangle first. So for instance, if I said FE of the smaller triangle, which side does that match up with? BC. Okay, so right there we're just talking about the ratios comparing corresponding sides of one triangle to the other. Alright, so let's go back to what this property was telling us. Ratios of lengths of corresponding sides are equal. Okay, so let's go ahead and write all of the ratios of the lengths, comparing big triangles to small triangles. Okay? So let's go ahead and write the length of AC, which is 9, and what is the length of the corresponding side on our smaller triangle that would match with AC? 3. Okay? Let's do AB now. What is the length of AB? 3. And the corresponding side on the smaller triangle would be 1, which is DE. Lastly, BC, which is 6, corresponds to side FE, which is 2. Okay, looking at our property again, it says that these three ratios are equal. Is 9/3 equal to 3/1, which is equal to 6/2? If we were to reduce all three of these ratios, we would see that they all reduce down to 3/1, so yes, they are indeed equal, which is what they should be according to our properties. Alright, so just to clarify, and looking at those two properties one more time, the first property, if you look back, says corresponding angles of similar figures have the same measure. So look at this, look at these two similar triangles. Do you see how the matching angles all have the same measure? Okay, so that property is taken care of. The second property, again, says the ratios of lengths should be equal. Okay, so let's just look. Let's compare the big triangle to the small triangle and write all of the ratios. So 2 goes with 1, 4 goes with 2, and 6 goes with 3. Do those all reduce down to the same thing? Yes, they all reduce down to the ratio 2:1. Couple things about this special number. This is called the size change factor, which was from our lesson on Thursday. Also, new to this section, this is called the ratio of similitude. Okay, so that's new vocab. And in this case, the ratio of similitude that we're looking at is from the big triangle to the small triangle. Okay? Alright, so let's see how we can use this to solve some problems. In this drawing, we have two quadrilaterals that are similar. Okay, so again, knowing that all corresponding sides have to have equal ratios, all corresponding angles have to have the same measure. Okay, so let's go ahead and set up two equal ratios between the two quadrilaterals we have here, and we can use our proportion work to solve for x. Okay, so we could set up a proportion. Let's do small to big. It won't matter if you do small to big or big to small as long as you do it the same for both ratios. So the side of the small quadrilateral, that is 2, matches up with the side of the large quadrilateral, that is 3.2. We can set up this proportion because we know these ratios are equal. We want to start with our small quadrilateral again, and x matches up with which side? The side that is 4 of the large quadrilateral. So from here, we have a proportion. We know how to solve this. Cross multiply. If we go ahead and solve that, we would find that x is 2.5. Okay, so we are using our proportion work, means, extremes, cross multiplication, along with the properties that we now know about similar figures. Alright, here's a second example. These two triangles are similar. I would like you to take a chance, go ahead, see if you can set up equal proportions, equal ratios of proportion to help you solve for h. Again, you can set up it to be small comparing to big or big comparing to small, as long as you're consistent. So take a few minutes, solve for h. Alright, if you took the time to do that, 3 and h correspond, as do 4 and 72. And you could go ahead, and hopefully you did this, cross multiply, solve. 4h is 216, so then we know that h is 54. Alright? Alright, here's some extra practice for you. We have two similar figures here again. The sides are marked accordingly. Your tasks are, first, try to find x and y. Then also find the ratio of similitude. First find it big to small, small to big. Okay? So pause, try to solve these, see if you're getting the right answers. Alright, here are the answers. If you did not get the right answers, go back, check your work, or ask for help. Okay? So to quickly review what we talked about, similar figures are the same shape but have different sizes. The angles that match up in your similar figures have to be equal, and the sides that match up have to be in equal ratios. That, again, ratio is called the ratio of similitude.